Hey, this is lesson 6 or 7 or something, an SQL course. This week we are looking at other types of joins. Last week we saw the inner join and how you can start to combine tables and their data across foreign keys, primary keys, so on and so forth. This week we're going to look at left joins, right joins, full joins, self-joins, unions, and subqueries. These are, again, all ways to start using relations across tables. This is really, along with the inner join, the only ways that you can join data across different tables together. And we're going to see some use cases where an inner join simply won't work to get the data that we need, so we're going to have to use the left join, the right join, the full join, the union, the self join, and the subquery to do it. And I've tried to give examples that are not possible using any other thing other than what is given. Within SQL, there's a lot of ways to do different things as there are in programming, but these are kind of the shortest ways and the easiest to understand these types of things. So there's going to be one example for each, and then there will be an assignment following. So we're going to start out here with this left or right join. So we've got the problem here. It says give all the users in their schools, regardless if they have one. So when we look in here and we have these tables, we have the users, and then we have users' schools and users unavailable schools. So what this question is really asking is it's saying all of their available schools. So when we talk about this users schools table, linking it with this users table. So last week we saw something a little like this. I'm going to copy it and run it. I've got all my code here so you guys can see it better than when last week I was trying to write it at the same time. So I'm just going to go over here and make a quick edit to this. Let me quickly. Okay, so if I just take all of the people and users, right, and I just run this, okay, it's saying 54 rows of data are coming back. So 54 rows of data. Go ahead and leave that comment on there. That's just telling me that there are 54 users in the system. If I then take a statement like what we would have written, last week, this one here, select the ID, the alias, and the school from users, inner join users schools on users ID is equal to users schools.user, and we'll order it by users ID. So this is it's gonna join the tables together, right, using an inner join. So if I go ahead and I run this, you'll notice it says retrieving data 52 rows. 52 rows of data. So it's missing 2 users. So the question said, give all of the users in their available schools regardless if they have one. We know that we're missing 2 users, which, we know means, okay, well, there's 2 users that have unavailable schools. Either that or there's 2 users that got set up wrong. Regardless, we're still missing 2 users. And that's kind of unacceptable. I don't know if I have a drawing program on this computer or not. I suppose I have Photoshop. Just to give a quick kind of example of what I'm talking about, they call these things Cartesian products. And what it means is that you're selecting from 2 different data sets. And you guys have all seen, let's see if I just do something quick here. So if we give a red one, so when, if this is a data source, let's try that again. If this is a data source, So we have a red data source and a blue data source, right? This is, essentially, let me initialize my type tool here. This is essentially the users table, and this is essentially users schools. When we talk about the Cartesian product, when we talk about joining something, if I go ahead and throw this on, multiply, what they're talking about is that darkened area in between there and kind of how it comes back. We're talking about this area in here. This is the inner join, right? This is the inner join. That's what we're getting back. We're getting back the data that exists in both sets. So we have 54 users here, but only 52 of them have data over here. So that's all we're going to be able to get is 52 rows back from that. So when we talk about a left join or a right join, what we mean is that we need to have not just this little bit here, but rather this entire circle and this little bit. So if I can draw this on here in possibly a different color, go purple. So if I say I want a left join, what I'm referring to is this entire circle and this part here. If I say I want a right join, let's go with green. A right join would mean I want all this data and this little bit here. And then the dark part is still the inner join. So what does that mean in terms of what we're talking about? Well, when we did the inner join just now, we got these 52 rows of data back. Well, what if I then change that? If I change it to this, this selection here, which you'll see is using a left join. And I run, I've got all these things running. It's not a problem. It's going to run this, then it's going to run this, then it's going to run this. And we run that, it's saying, oh, I got 54 rows of data. So we know we got everything back. So if we start to scroll through this data here, what you'll notice is that there are two users in the system, 51 and 52, that don't have a school associated with them. But they still return in the data. Right? If we go back, okay, remember 51 and 52, if we go and we were to take this out and we're to run this inner join again, you'll notice that users 51 and 52 simply don't exist in the data set. Right? If we think about it from here, 51 and 52 don't exist in this black part. They exist here, but they don't exist over here, so they don't exist in both. So when we say, give me the left join, what we mean is, give me everything in users, regardless of whether or not it actually exists over here in this users schools. So 54 rows, 51 and 52, here they are. They don't have any data, but yet they're still returned because I want all of the users, not just some of the users. And the left join just means everything that comes before this join, so this part. If I were to say right join, it would mean this part is what I want all of returned back. So if we do that, you'll notice that we're back to 52 rows because user schools only has 52 rows in it. It doesn't make any sense. There is no more data. The inner join is enough there. But there are more things in users than there are in user schools. We could do this, another way and look at, well, what users have unavailable schools? Give me all those users, And we should still have 54 rows because we're still left joining, meaning give me everything in users. Column school does not exist. Let me see what's in this one. Unavail school. It just has a different name. So when I run it, you'll see, okay, I still have all the users, just only these two now actually have any data. So that's kind of how the left join and the right join work. Right join just means, hey, join it with this thing. Left join just means, hey, join it with this thing. Right? It's just kind of this before and after. And it really, you won't kind of maybe even need a right join until you start getting statements that are quite long. What I mean by that is, you know, it might have 10 joins in a single statement, at which point, you know, you need to specify whether or not the data before or after the join is what all of needs to be included. So that's kind of, you know, the gist on left or right joins. The inner join didn't work simply because it didn't contain all of the users. It only contained the matching users. So it only contained, you know, this middle section here versus all of the users, regardless or not, you know, they had data. All right, so that's left joins, right joins. You know, if it's left, it gives you everything from the left table and whatever matches in the right table. If it's right, it gives you everything from the right table and whatever matches from the left table. Okay, so moving on from there, we've had inner, which is the inner part. We've had left, which is the left. We've had right, which is the right. Well, what if you want this whole thing? What if, we'll do it in a yellow color. What if you wanted, you know, I want basically this. I want everything. You could kind of, if I were to draw better, you could probably think of it as like the infinity symbol. You know, come down here, this will come down here. But we're getting everything. We're getting, you know, this part, and this part. So that would be called an outer, a full, you're not going to be able to see this very well, but it's called a full outer join. And let's go down and take a look at that. So it's called a full outer join, or just a full join. So you notice up here there's left join and the right join. They're actually called left outer join, but you don't need to use that. And the outer, you know, if it's not inner, it's outer. That's how you know. So this one's called a full join, or a, you know, full outer join. And the example I've got here is give all of the users and all of the access levels for users, even if there are no users with that access level. So if we come in here and I say select star from access, just to kind of see what's in there. You know, we've got these admin, super, and master roles. And then we've got another table which is called users access. And it's only got one user in it with any access. Okay, and then we obviously have the users table. So this said give all of the users and all of the access levels for users, even if there are no users with that access level. So, you know, right away we're knowing, okay, well, I'm going to get something from users, and what do I want to do? I want to join it with their access, but I don't want to limit it just to the users who have access. I want to get all of them, right, regardless if they have it or not. So I'm using a left join there, and then I'm going to go ahead and join access, and I want to join fully. I want everything that's up here, and then I also want everything that's in here, you know, in this access table. So if we take this thing and we run it, you'll see kind of, you know, a better what I'm talking about. It's going to give us back 56 rows of data. We know that there's only 54 users. So what does that mean? Well, it means that we're getting all of our users plus 2 extra rows. Why? Well, we'll see here that, you know, it gives us not only the user data, you know, their email, their password created, blah, 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 things we've all seen before, but it also gives us this information from the user's access table, which is right here. It gives us the user ID again and the access. It then also links us to the access table, okay, and this is the access ID and the access role. Okay, so that's fine. It gave us, these things. But then at the bottom it also says there's also 2 access levels that are never used anywhere, which are super and master. And it tells us that they're never used anywhere simply because there's no users that have it, so it's not associated with any user at all. If there were, even a single user that had super, it would simply, not show up down here. Same with master. So that's the full join. It means that we want everything from both tables that are being joined. So when we think about this full join, think about this entire thing as one join. Even though it's got a join in it, think about this as one data set. And we want to join it fully with this data set. We don't want to limit any part of it. So that's kind of, the full join. And I don't know that there's any problems that I'm going to give you with this, just because it's kind of a weird one. The book, I think, has some examples. I've got another book which has an example of using, there was a bunch of movies in a database and then ratings, like G, PG, things like that. And they had like a rated PG-13 in the rating system, but no movies had PG-13. But they still wanted, that rating back with all their movies. It's kind of used like that, when you want a bunch of data that maybe doesn't all link up in both sides, but you want all the data from both tables, regardless of whether or not there's kind of like a relation between them all. So that's the full join. Okay, so we're going to look at the self join now. And the self join just means that simply that you join a table back to itself. And there's a couple of examples that you could see this in use for. The one that's kind of common is they say, okay, we have a table of users, and you have an ID and you have a name, and then maybe you have a manager ID, and the manager ID is also a user, right? So then I want to know all the users plus their managers' names. So we, pull out the name. Oh, then we have to join back to the users table on the manager ID with ID to get that out. So it would be something like, select this from users, and then we inner join. We could even do it left join. Maybe they don't have a manager ID. And you left join on itself. And what are you joining on? You're joining on, we're going to have to name this something different. Got to give it an alias. On users manager ID equals u2.id. Right, and that would basically say, okay, go and select everything from users. So it's going to give us all this data. Left join, meaning, give me every ID. Left join with itself, and we'll call that U2, on the manager ID equals this ID. It's going to give us back then all the users plus their manager and their name. Okay, so that's kind of the really common example that's given everywhere. I've gone with kind of a more difficult one, and we're going to build it up here. We'll kind of go through it, as we do this. So the problem I've given you says get the comments and authors for all the comments left on notes added by the user Lakesta. Okay, so we know initially that we're talking about the user Lakesta. That's kind of where we want to begin this statement. So if we come here and we say, kind of cut this out. Select everything from users where users alias is Lakesta. Right? We've seen that before. We know it's just a simple where clause. That kind of gets us this part here, the user Lakesta. Well, what do we want? Well, we want, comments and authors for all comments left on notes. So the first kind of step here is that we're going to join up with the notes table on notes author equals users.id. And that's going to get us all the notes that belong to this user Lakesta. We've seen that before. That shouldn't be anything new. Okay, so the next step is getting comments for all of those notes. So it's another inner join. We've already got the user Lakesta. We've got all the notes that belong to that user. Now we're getting the comments, and the way that comments in the system work. So we've got this note comments table, and it links a note to a comment. So they're just based on IDs. So we're saying inner join this note comments table and see on where the note is equal to the note's ID. From there, we need to get the actual comment itself. So I'm going to come in here and I'm going to say inner join comments on comments.id is equal to this comment. So we noted that this note comments is just a linking table between the notes and the comments. It has a note ID, it has a comment ID. Well, comments themselves are things, so we look up here in comments, they have an ID, an author, and a comment. Okay. So we've been able to get pretty much all of this other than the authors so far. So the last part that we're going to add on here is just we're going to rejoin users, right? Our initial select was from users. We wanted to get this user Lakesta. We now want to join users again. This is where the self join comes. We're selecting from users. We're now joining back to users. Where the author of the comment is this ID. So if I go ahead and I run this, we can even piece it out as we run it if you wanted to see that kind of done the way it was done. So initially, I said, hey, select from users, where users.alias is Lakesta. Okay, we're going to get that user. If we join up then the notes that belong to Lakesta, you'll notice we're now getting 12 rows back. Each row is going to have the user, but then it's also going to have the note over here. So here's all the note data. The next join was to get comments and notes, and which is going to shrink us down to just one row. Only one note has a comment, and it only has one comment. So if we come over all the way, we already seen the user data, we've already seen the note data, we've kind of got this last part here, which is, okay, this note 14 has a comment, and it's comment number 1. So when I go ahead and I join that back to comments, we'll see, okay, we've still got this one thing. Let it load. Okay, so here was where we stopped. Here's the note comment table. Here's the actual comment. The comment has ID of 1, it has an author of 18, and here's the comment itself. Well then, I want to know who that author is. So I threw on another inner join to the comments author. And you'll see here we're going to have, basically our data that's going to be returned is user, then note comments, then another user. So here's, user 1. If we come all the way back over, kind of here's the next user, user 18. Sorry about that. User 18, here's the alias, here's their email, so on and so forth. So we could, really kind of limit this back down to say we want users alias, which is going to be Lakesta. That's, the user we're looking for. We could then say we want the note ID. Then we want the comments, the comment. And maybe before we get that comment, we want the U2 alias. So U2 is the user the second time. So if we were to run that, here's the original author of the note. Here's the note ID. Then here's the comment and the author of the comment. So we could, do something like this. Add some aliases in just to make it a little more obvious. We've got the note author, we've got the note ID, we've got the comment author, and the comment. If there were more comments, they would show up here. So that's using a self-join back to users to be able to figure out who is the author of this note. and you'll notice it's a bit long there, but for good reason. And this is what I was talking about previously, saying with the right join type of thing, you might need to use it once you get multiple joins. So you'll see here we've got 4 joins going on just to get the data that we want. And then you notice even when we get the data, we have to really specifically go in and state how much of that data we want to see, because there's really too much data coming back. So that's the self join. It's a join from a table to itself, and you're gonna have to alias it again, because if I were to write, if I didn't do this and I said users.id, it's not gonna know which users I'm talking about, this one or this one. So you're gonna have to alias it. Alright, so next thing here, we've got this thing called a union. And the way a union works is, say you have 2 select statements, and they're totally separate. They're totally separate things. But you want to join their result sets together. Previously, everything we've done has been a single select statement. Even we've got a self join, there's 1 select. We've got a full join, and we're getting data back from 2 results sets. Here it's even 3, but 2 fully, but it's still only using 1 select, meaning we can't have any really specific things going on. It's just kind of, hey, that data is all going to be merged together, or rather not merged together. It's going to be column, 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 column. Even if the columns are the same, they're going to be separate, right? Well, what if you want the columns to be together? So here's the question: list all the schools in the system, regardless if they're available or unavailable. So we have 2 tables. We have schools and we have unavailable schools. I just want the names of all of them. So if I run this, right, it's going to give it to me. Here's all the names of all the schools in the system, whether they're available or not. Which is pretty awesome when you think about the fact that if we go and we look at these 2 tables, right, if I go to schools and I look at it, you'll notice there's ID, name, city, state, country, image. And then I go to unavailable schools. There's an ID and a name. There's nothing that actually links these 2 tables together. Schools and unavailable schools are not linked together in anything except that they're similar. They're both talking about the same things. They're both talking about schools. So we can get all of the data together by using a union, which is pretty cool, because of solving questions like this. Give me all the schools in the system, regardless if they're available or not. Well, you just take these 2 select statements, union them together, order it by name. It orders the whole result set, not simply one of the result sets. It gives you everything. So there's 19. If we were just to run, this first part, we only get 18 things. So there really is an unavailable school in there. If we were, only to run the unavailable schools, but we'd only get Wright State University. This union, we can get everything. That's pretty cool. All right, so last thing coming up here are subqueries. So the question here is, give me the users with notes whose average price is greater than $5. So we know we're looking at the users table, we're looking at the notes table, and specifically the cost column of the notes table. Okay, and there's 2 ways to go about this statement. You can try to do, like a join with a group by and, a having and those types of things. But really, it's simply easier to use a where clause with a query inside of that where clause. And there's 2 ways to go about that. There's the uncorrelated and the correlated. And what the uncorrelated means is that the inner clause here, this inner select statement, works regardless whether or not it has this outer select statement. They're unrelated, basically. The correlated version is going to, this inner select statement is going to require the outer statement in order for it to work. Okay, so we're going to start here looking at this uncorrelated one. We want users with notes whose average price is greater than $5. Well, we can select the alias because that's what we want. We want the users. We can select the alias from users where the ID, so where the ID of the users exists in this list. And we're going to create this list from another select statement. The other select statement says select the author from notes, grouped by the author, having an average cost greater than $5. So if we go and we run that, it's pretty straightforward. The new thing here being that our where clause now has a select statement in it, which is kind of a new thing. Well, we get these 4 users back, Dustin, Chapulin, Zaya, and Lakesta. So they're the users whose average cost is greater than $5. And that's kind of the uncorrelated way, I'm just getting the user back. I don't really have a way at this point to get the cost. It's not available in the users table, and I'm not really returning anything from this one. So we just know the author at that point. All right, that's fine. That was the question. Solved it. So in the correlated way, it looks, pretty much starts the same. Select alias from users. Where, and the where is what's different. We're not asking any longer for the user. Here we've got this other select statement. It says select the average cost from notes, where notes author is equal to users.id. It's kind of like a join, like an inner join, that we've seen. Basically, inner join notes on notes.author equals users.id. Right? We've seen that before. It's the same type of thing. And we're grouping by notes author still, same way that we did here. And this result, what this gives back to us is the average cost, right? Where, we've got this parenthesis holding this in. So it's going to give us some number back. And it's related here on the author being the user ID that's coming from each of these rows. And then we just have this here hanging out afterwards, basically where whatever comes back from this is greater than 5. Pretty much the same thing we had up here. It's just written a little differently. It's written in that it's a correlated select so that it requires this first part. So we saw Dustin, Chapulin, Zaya, and Lakesta. If I were to run this new one, we get the exact same thing. I can run it and show you the exact same thing. It's just kind of a different way of looking at it. Both of them work. It's just some people see things a certain way and others see things a different way. They both work. I'm fine with either, whichever one makes more sense to you. There might be a use case where you can't think of one in a certain way. It's fine. Either one works. You don't have to use one all the time. Whichever one works for solving the problem that you're given is what's important. So that's it. We've covered the left join, the right join, the full join, the self join, the union, and subqueries this week. So I'll give you some problems based on those, and any questions you have, make sure to let me know. Thanks.